Welcome to Science 9 in the AM. We're in progress right now. We're measuring amps, the level of the current for these batteries. And right now, this is Team Gary, by the way. Hot dog, we got another say thing. Anyways, I just want to run through what we have. And I said, I'm not concerned whether your meter reads negative or positive, but you do have to have a complete circle. So right now, it's got current goes through the light bulb into the ammeter, and current is measuring the flow of energy, electrical energy, going through this meter and back to the light bulb. And I don't care if you trace it, or if you think of it going from the negative to the positive, which is actually the way the electrons go, or if you go positive to the negative, as long as it's a complete loop, circle, okay? Right. And I'm going to get a quick poll of what we have for readings. It was 19 or 20, 19 or 20 it flutters a bit, right? 19 or 20? Yes. Okay, you guys? 18? Okay, well, this makes sense. Some of these batteries are quite old. You guys? 1920? And your meter just wasn't working. Does it work now? Unknown. So, you know what? Should we go with, let's just go with 20 for easy math reasons, but some of you will be 17 or 18. Now, I'm just writing down this. You guys write down, if you guys got 17 or 18 consistently, write that down too. So, here's the silly thing, and I'm going to write it in words. Current, and then the letter I. Don't know why, but that's what physics uses for a variable. Is equal to, and I'm going to put the decimal 20A amps, okay? Now, what do you think the logical thing, and I've seen somebody already do this, and I'm sure they're not going to. What do you think the logical thing to do now is? Add a second battery. Let's see what we get. Okay. I'm going to just put one battery. Okay. And same setup. I'm going to pause and double check with the back group again here, but I don't think our cable is working. When we add the second battery, two batteries, we're going to write that down first. What do we get for currents? I heard 28, 25. Okay. You guys still working on it? What'd you guys get? 26. It's not adding up to just double though, is it? Okay. I'll use the 28 just because I hear you guys, but yeah. Okay. So not really a major increase. Okay. We know that the voltage doubles though in this case. Do you remember there was another way to add a second battery that I showed you and it didn't do anything to the voltage? Does it do something to, I'm going to just, the wire thing, yes, and I'm going to just grab myself a couple of bulbs. Grab the whole deal. Because that way doesn't seem to really affect the voltage in any significant way. So this way isn't doing anything. Do you guys remember the other way? I know Shane does because he's mentioned it. What if you take the copper wires, connect bottom to bottom, top to top, positive to positive, negative to negative, and you guys got enough hands to do this. And then, I guess I'll use this, alligator clips, alligator clips. Let's use this for the ammeter. Uh-oh, what did I do wrong? No. Okay, there we go. I got a complete loop. Try it this way, and if you need some spare copper wire, I'll grab it for you. I'll pause the video while we see what happens here. Now, the next thing we're going to try is, I'll get you a second light bulb and base. How could you wire up 2 light bulbs? And I'm not going to tell you, just like the first time we did this, you guys figure out a way. And I traditionally, when I've done this in the past, there's one way that most groups come up with first, and the second way they don't. One is called series, now, and one is called parallel. And I'll tell you this, you kind of understand series is usually the one people come up with first. And what is a television series, or what does series mean outside of science? That come one after another. Like if it's a TV series, The Simpsons you don't need to watch in order. I'm old, so I'm coming up with an old show, right? You don't really need to watch them in order to understand. But there's a lot of shows, if you watch something like Grey's Anatomy, or I don't know, ones with a continuing story, you actually have to watch the series in order, right? So they're one after another, one after another. That's the best way to watch them, right? It's kind of the same meaning in this light bulb example. The other one in parallel is something different. And I had one group about 2 or 3 years ago come up with parallel first. And I was like, wow, that's the first time I've had a group come up with parallel first. Now, you guys experiment, figure out a way to hitch up 2 light bulbs. I'll get them to you right now. And then we're going to measure some things too. But first, just come up with the way to measure it, and then we'll worry about measuring bolts and stuff. I want to make sure. That we're able to do this. We're not actually worried about the readings right now. This was a different group. I'm going to erase some things because it'll be different this year. Okay. Yeah, there is something to do with your battery setup. Okay. Don't worry about the blue arrows right now, but did you guys have it set up like this, whether you use 1 or 2 batteries? You guys should only use what? Which battery is the what? Okay. Okay, so get this down in writing, okay? I'm going to pause the video while I go hunt around and see some things. Okay, guys, one thing I want you to try, get this down. You have the, I'm hoping you have, how could you wire up 2 light bulbs? Then we're going to take a look at voltage and current, okay? But get this diagram down. And we have the 1 volt meter. Remember how we hitched that up? Are you getting energy from Taylor Swift? Wow. Anyways, get this diagram down, and we're going to talk about how to measure the current and how to measure the voltage, the potential draw. First, you need this down, though, and then we'll talk about that. Okay? I want you to do, I guess since we have the ammeters more or less working except for that group, you remember how the ammeter has to be inside the loop? So what you're going to do is, and I'm going to get my map, you're going to take your ammeter, and why isn't this work? I'll try to get, there we go. You're going to make the ammeter part of the circuit right here. You're going to do that. Then you're going to check the ammeter right here. And then you're going to check the ammeter in between the bulb and the last battery. Or the last connection to that. Okay? Can you guys do that right now with your ammeter? Check it in all 3 places by inserting it into there, okay? I'll come around and help. Let's get some readings though. I'm going to pause the video recording and we'll see what we got. Anyways, I'm going to get a collection of readings from the groups that got them so far because we've got to put stuff away in the next minute. So, what I'm going to do is when I put the ammeter between the bulb and the first bulb in the battery, what did you guys get? What's that? 10? Okay, you guys got 3, you guys got 19, I think it was. You guys got 19, 20, or 18? 18? Okay. Depends because some bulbs are older and more used than others. Okay, then when you put it in between, I'm going to just go with 18 for this. You guys got 20, you guys got 18, 19, about the same reading. You guys get about 20, okay? Same reading-ish. Within a decimal, sometimes 18, sometimes 19. They flutter. I'm going to just use 18 just to. And last one was also, right? I'm going to use 18. Now, the whole thing is does this make sense? We're measuring current. And for a second here, we're going to imagine this is a water pump. Okay, I want you to pay attention. Does this make sense? I'm going to say the electrons are coming out the rear end, the negative. Does it make sense that if, I'm going to talk liters, if there's 18, but I put V there, that's no good. Just a second. It should be A or S. Okay, back to this. If there is 18 liters of water coming through this pump, how many liters of water in a minute? 18 liters of water, let's say in a minute. If there's 18 liters of water coming into the bulb, how many liters of water should be coming through the middle? 18. Okay, this is starting to make sense. And then the 18 liters of water, within reason, return to the pump. The pump, the electrical pump in this case, is the battery. Is this making sense why it's the same on all 3 spots? Not really. Yours is, and I'll take a look at it with you. I don't know, and I just said just don't do it because it did it 3 times in a row. Okay. What I want you to get down, and I'm going to take a look at Peyton's group in a second here, is whatever reading you had. Now, some of them were 17, some were 20s, but they're reasonably the same. I want you to write this down. This is called a series circuit. But that's all because we haven't done the voltages yet. So just write down, this is called a series circuit, okay? And I'm going to stop the recording for now. I'm going to look at Peyton's. Can you guys clean up? Turn the meters to off and set them on the side again for tomorrow. Awesome.